In these last few examples, we're going to take a look at some more complex functions that might require more than one derivative rule. So we might be using a product rule and a quotient rule, or a quotient rule and a chain rule. And so we're just going to hop right in here. First up, I've got y equals 2e to the x times x cubed minus 6 raised to the 5th power. The first thing that I notice when I see this, I see 2e to the x times x cubed minus 6 raised to the 5th power. There I'm multiplying two different types of functions. So the very first thing I notice is we're going to have to use a product rule here. The other thing that I notice is when I take the derivative of this piece right here, x cubed minus 6 raised to the 5th power, there I'm going to have to be using my chain rule. So I see a product rule and a chain rule here. Now, once I identify that I'm going to be using multiple derivative rules, I really like to slow down this process and kind of go back to basics. Take your time with these problems. So when we were working with the product rule way back when, we said, okay, here's a function f, here's a function g. I'm going to, go way back to the beginning and say, okay, f is equal to 2e to the x power. G is equal to x cubed minus 6 raised to the 5th power. And here I'm just slowing this down as much as I can. So I know for my product rule, I'm going to need to find the derivative of each of these two functions. So f prime, the derivative of 2e to the x, is just going to be 2e to the x power. G prime, here's where that chain rule is coming into play when I take the derivative of g prime. So I'm going to go ahead and use my shortcut here. I'll multiply by my power 5. The inside part of my function is going to stay exactly the same. So this is going to be x cubed minus 6. Subtract 1 from my power. So now this is to the 4th power times the derivative of the inside part for my chain rule. So I want to multiply by 3x squared. And before I begin to simplify before I begin to start plugging anything in, I do want to go ahead and simplify. I see 5 times 3x squared. Let's just multiply those two together so that we have 15x squared times x cubed minus 6 raised to the 4th power. So there is our g prime. So we've got f prime, we got f prime, g, and g prime. Well, now we're ready to go ahead and apply our product rule. Now, our product rule, we said when we're taking the derivative of our product rule, we're going to have f prime times g plus f times g prime. And what's nice about slowing this process down is I already know exactly what f is, what f prime is, what g prime is. I've got everything all laid out over there in blue. So I'm just going to go ahead and plug in what we've got. Y prime is equal to f prime, so that's going to be 2e to the x. And I'll highlight these as I go along. So f prime I'm pulling from 2e to the x times g, so that's going to be x cubed minus 6 raised to the 5th power, so times x cubed minus 6 raised to the 5th power, plus, next up, I've got f. Well, f, that's 2e to the x, so plus 2e to the x, times g prime. G prime, we simplified that to be 15x squared times x cubed minus 6 raised to the 4th power. So this I can write as 15x squared times x cubed minus 6 raised to the 4th power. And at this point, there's my derivative in its kind of most basic format. I haven't done any simplifying here whatsoever, but this is my derivative. Now, if I did want to go ahead and simplify this, and there will be problems where we might want to say, find where we have a horizontal tangent line. It might be helpful for us to factor this because as it's written right now, this is really, there's a lot going on here. It's not very user-friendly. So you might want to factor this. I see, first of all, a common factor of 2e to the x in both of these, so I could factor out 2e to the x. I also see a common factor of x cubed minus 6 raised to the 4th power. Here I've got 5. I can take one away, so I'll still have one of those left for that first term. So I'm going to factor those two pieces out first of all. Y prime is equal to 2e to the x times x cubed minus 6 raised to the 4th power. And then, okay, what are we going to have? After I factor this out, I'm still going to have x cubed minus 6 raised to the 1st power. So I'm just going to write that as x cubed minus 6. If you want to write that in parentheses and put it to the 1st power, we can do that too. Plus, well, I've got this 15x squared left over. So plus 15x squared. If I can, I would want to go ahead and combine any like terms on the inside of my parentheses here. In this case, I've got an x cubed, I've got a constant, I've got an x squared term. Nothing's really going to simplify. Really, the only thing I would do, I would drop these parentheses. I think they're more confusing than they're worth. And I would probably just leave my solution like this. I think this is kind of the nicest possible way that we can write this derivative. For right now, for this section, when you're very first starting off, if you want to leave your answer in this unfactored form, I think that's okay. But I think it's really, really good practice to try and factor this and trying to write this in a more user-friendly form so that we can do more cool calculus stuff after we find the derivative, like, say, write the equation of the tangent line, or find where the function has a horizontal tangent line, because that's cool calculus stuff too that we want to be able to do.